Hey, 8th grade group, I wanted to make a quick video today, which is Friday, to go over how to use your patty paper better. And then also we'll go over this on Monday and Tuesday next week. Prep you up for Thursday if you're period 2, Friday if you're period 4 for your test. It would help you. So I'm using right now my whiteboard. I already drew some shapes on there to make this video not so long, to watch me draw them. And then what I'm gonna show you right now, hopefully then you can translate or use that idea, slide it from here to here. As you can see, I just on my computer have a random picture of shapes, but I used it on my computer. I just stuck the paper on the screen and traced them. Like I mentioned earlier though, I did it with a pencil on the screen just so I did it really light because I didn't want to puncture or scratch my screen. And then I set the paper on my table and went over it with a marker. So easy thing to do. Now, the thing I'm talking about, you should have got some in your kit, but if you didn't get some, this is what mine look like. I don't think you got this massive box. I bet you just got a couple of them, but they're called patty paper for like if you're making hamburgers, you put them between it so they don't stick together. It's just a small, I don't know, 5.5 by 5.5 inch square piece of wax paper is all it is. So if you didn't get any, you can just use wax paper if you have some in your kitchen. I even just used a piece of notebook paper. It was see-through enough that it worked too. So either one of them is fine. So what we're looking at is using the patty paper for the shapes. We can outline the shapes and be able to tell about the translation, rotation, reflection, see if it's a rigid transformation. So I'm gonna go over all those and I'm gonna try to go fast so my video's not too long. But for the first one over here, this is my 2 images here. This one's my pre-image because you can see it doesn't have the ones and after it. This is my what we call image. So pre-image, pre means before. So this is your first picture, this is your second. So we started here and we went to here. So what you could do is you could take your patty paper, trace the shape. Now the first thing you can do now that you traced it is you could slide it or translate and put it over. And now we know, okay, look, it is the exact same. So we know they are congruent. Because if it wasn't, then right away we know that's not a rigid transformation, right? If it changes, it's no longer a rigid transformation. So since all I did was slide the patty paper down, I know it's just a translation. There's no rotation, there's no reflection because it never changed the direction the shape's going. So now what you could do is, I'm gonna use this point right here, and it looks like to go from A to A, it goes down 1, 2, 3, 4, 5, 6, 7, and over 1, 2. So if this was a test question, I would answer it by explaining that the pre-image was translated down. See how I mentioned it was translated? I told you what direction it was going. Some of you aren't doing that. And then the third thing I'd want to mention is how many. So I would say in my answer that the pre-image was translated 1, 2, 3, 4, 5, 6, 7. It was translated down 7 units, and then it was translated left 2 units, 1, 2. Watch, 1, 2, 3, 4, 5, 6, 7, 1, 2. That's the test answer right there. Like, tell me what it did, translate, rotate, reflect, which direction it went. I said down, and then I said left. How many? It went down 7 over 2. That's a money answer right there. So that's translate. Let me grab another piece of patty paper. Over here, I'd say the toughest one for a lot of you has been rotate. Now, as for rotate, image 1, image 2, so it's easy to tell which one went first. Excuse me. So the thing you got to remember with rotate is where is it rotating from? The point of origin, the point of rotation, excuse me. If I said it was rotating on the corner of this shape right here, and I rotated it 90 degrees, look, it doesn't match. What does match is it's going the right direction. So at least we know that it was 90 degrees, and I'll show you a little cheat I came up with for the 90 degrees. I stuck it there, and I made a mark right at the origin just so you could see. And obviously 90 degrees is an L, so if I just put my pencil where I want to rotate it, and I watch these 2 lines right now, if I rotate it till they're perfect again, that's 90 degrees. And look, it lands exactly. So if this was a test question, my answer would be shape 1 was rotated, there's one part, 90 degrees, that's the second part. And then the third part, clockwise. Some of you were saying it rotated 90 degrees right. That doesn't make sense. So it's clockwise or counterclockwise. So to get the 100% on the test question, what did it do? It rotated. How many degrees? 90 degrees. Which direction? Clockwise. Boom. And then my last, I guess, transformation to show you is a reflection. The one thing to remember about the reflection is, as you can see, it reflected. So I would say on my test question, reflected down and across what? Now, if you said this is x-axis going this way right here. If you said it reflected down across the x-axis, you would be wrong, because if I took that line and now I flip this over and stuck it right back on that line, it does not land there, right? Did it reflect across y equals 1, right? Negative 1, excuse me, I'm down 1. Let's flip it over and see. Put it on the same line. Don't put it up there, put it on the same line. I'm getting closer. So if I moved it down another one, y equals negative 2. It's that line, so we're gonna stick it right back in the same spot. There it is. See, we lined up, it's on the line right here. So I would say for this full answer that it reflected down across y equals negative 2. This is negative 1, negative 2, negative 3, and so on, right? And then the last real quick thing I wanted to show you was, I already mentioned it. If this is shape 1 and this is shape 2, and it says, what transformation did it go through? What rigid transformation, I should say. If I trace this, and then it looks like, oh, it just translated over. But look, I don't know how well my phone can pick this up. They are not the exact same. The one behind it is only going like this. So my answer should be, it was not transformed. It's not a rigid transformation because the shape changed. It's no longer congruent. Hopefully that helps you guys. Go Hawks.